Hello everyone. My name is Vivek Pandey. I am Senior Solution Architect at Zettascale Technology. So we are the company who developed middleware technology. So we have Cyclone DDS, which is RMW in ROS2, and along with that we have our new middleware technology, that is Zenoh, Zero Network Overhead. So today I am going to talk about ROS2 communication optimization using Zenoh ROS2 Bridge. So we are not just optimizing the ROS communication. We can scale ROS2 system using Zenoh as a middleware technology. So before dive into how to optimize ROS2 communication, first we should understand what are the challenges we have today in ROS2. So as we already aware about DDS is a middleware technology in ROS2. So DDS itself is a very powerful technology. It is a very nice when you have plenty number of resources in terms of CPU, in terms of memory, and network bandwidth. But when you want to scale your system, or you want to add some network constraint devices or low powered network, at the time you run into several issues. So why do I say that? Because in DDS there is a discovery protocol. So each and every participant discover to each other. So for that they exchange the discovery messages, and DDS leverage the UDP multicast for this discovery. And in some system UDP is not supported or badly supported, and if you have a loosey network, then again it creates a lot of problem. So once all the participants discovered, after that DDS discover all the readers, writers, quality of services, and so on. So for that again it publish a lot of messages. So in that way you can say you can see a lot of message need to be exchanged, which flooded your network. So this is the major challenge most of the ROS2 user is experiencing. On top of that, there is a reliability protocol. So where all the data writers need to maintain the state of all connected data readers. For example, if you have a writer which are connected with n number of readers, and each readers have some history, then your writer need to be manage the state of all the readers along with the history. So in that way, it consume a lot of memory. So you can say the reliability protocol what we have in DDS, so it is a resource hungry protocol. So again it is a bigger challenge in ROS2. So on top of that, we have a liveliness protocol. So DDS have a liveliness protocol. So each and every DDS entities need to assert liveliness into the system, so that you can know about your entities is having the relevant at the at a particular of time or not. So it need a lot of bookkeeping. So it consume a lot of memory resources. So when you want to scale the DDS system on internet, or you want to add some microcontroller, then you have to break that semantic. So these semantic are liveliness, number of matching data readers, writers, and topics, all so on. So you have to break that thing. So it is very difficult to scale the DDS system on internet as well as the low power or microcontrollers. So here on top of that, there is RPC over DDS. So RPC, remote procedure call. So it is a synchronous way of communication. On the other hand, DDS is a asynchronous way of communication. So when you implement the RPC over DDS, it is just like a jugaad. It means you have to create two topic, one for request and one for reply, and pair of data reader and writer. So in this diagram you can see if you want to use the RPC over DDS, then you have to create request reply topic and corresponding data reader and writer. And when your server connected with multiple clients and server send the response to the client, then it goes to all the clients because of DDS have the asynchronous way of communication. So it is client responsibility to filter out the response on basis of the request message, the message what we have into the request message. So again, it is it consume a lot of memory and it consume a lot of processing power and bandwidth. So it is just like extra fuel on the fire because you have already many challenges like reliability, scalability, and so on. So recently we got a report from Open Robotics itself. So here you mentioned it mentioned that a lot of problems that are associated with the ROS2. So Open Robotics get the feedback from the ROS user like you and specify all the, so they build a report. So you can see here there are UDP multicast for discovery. So already mentioned that in our last slide. And there is a problem with Wi-Fi because on Wi-Fi, if you are using UDP multicast and DDS inbuilt use UDP multicast for the discovery, so there is a lot of packet loss. So so you have to transmit a lot of messages. So it creates a lot of problem. It consumes a lot of bandwidth. And if you lost the liveliness messages, then you disconnect with the DDS system. And when you reconnect, then again you resend the discovery message. So in that way, your Wi-Fi network become non-responsiveness. So it is a bigger challenge in ROS2 using DDS. So out of box experience was not good because if you want to scale your system, then you have to configure a lot of network configuration, and for that you need a lot of deep knowledge about DDS. So it is not expected from the ROS2 application developer. And some vendors have some extension or some non-standard solution for the scalability. So if you use that, then you go into the vendor lock situation. Yeah. So Open Robotics collect the feedback about which protocol is solve the issue what we have in ROS2. So most of the users voted for the Zenoh. So Zenoh is a distributed protocol. So it is zero network overhead. So it is pub sub query protocol that unified data in motion, data addressed, and computation from embedded microcontroller up to data center. So it is very simple protocol, and at the same time it provides the simplicity for universal abstraction of computation in heterogeneous and distributed way. So this is a single protocol that unified data in motion. So that is simply done by the pub sub, and you can store the data into any data storage in heterogeneous way. And when you send the query, so you don't need to know about where your data is stored. So it is managed by the Zenoh only. And same time it provides the universal abstraction for the computation. For the topology, so you can run Zenoh on any topology. So you can run on peer-to-peer. So you can run on click where all the peers are directly connected to others, and you can use in mesh topology, where your peer are indirectly connected to other. And you can use Zenoh in a brokered communication, where your client are connected through the Zenoh router. So Zenoh router is a soft router, and it is very useful when your client have minimum resources, and it directly connect to that router and interact with the rest of the system. And you can do the routed communication by using Zenoh. So your router is running on, you can deploy your router on any geographical location across the world, and you can connect your system. So it is very efficient way to scale your system. And on the same time, you can plug some other. We have the plugin for the storage and with other protocols. So we will cover into the next slide. And you can run Zenoh on anywhere. So you can run on top of data link up to transport layer. So it supports different transport protocol like TCP, UDP, QUIC, Serial, Bluetooth, OpenThreadX, and it also supports the custom transport. And it have the minimal overhead of 5 bytes. So it is very suitable for low constraint and extreme constraint devices. So now Zenoh on MCUs. So you can run Zenoh on embedded devices. So we have Zenoh Pico. So that is built in C. The core of Zenoh Pico is built in C, because C have very rich libraries to support the MCUs, and we have a very nice blog, so where you can go and see about how Zenoh work on the MCUs and which MCUs supported on Zenoh. And in our last slide, I missed something. So the core of Zenoh is developed in Rust, and we have the binding for other language like C, C++, Python, and recently we released our Kotlin binding. So you can use Zenoh on your Android based device applications. So extensibility. So you can leverage your Zenoh communication, or you can scale your Zenoh based system by using the plugin. So we have plugin for different data storage. So you can store the data into the InfluxDB, RockDB, MariaDB, and S3 and so many. And you can connect your serial interfaces and microcontroller. We have the plugin for that. At the same time, you can use the MQTT. We have the plugin for MQTT and DDS also, and the REST to fetch the data from the RESTful APIs. And we have the plugin for the HTML server-side interfaces. And recently we developed our plugin for the ROS2 because in the ROS2 we have the DDS. So you send the traffic, DDS traffic to the Zenoh, and Zenoh handle the things, because in DDS we expose very minimal entities for the discovery, and we have very optimal solution for the reliability and liveliness. So it is very optimal. Zenoh provide a very optimal solution for the communication. So now come to Zenoh plugin for ROS2 over DDS. So first we in this slide you can see the mapping of ROS2 component to DDS. So here in ROS2, if you have the topic, so in DDS we have the corresponding topic and data writer. And if you have the subscriber in ROS2 component, then we have the reader at DDS side. And for the service and action, because they are using the RPC over DDS or RMW service in DDS. So for that you have to create for request reply, you have to create two number of topics, one for request, one for reply, and corresponding data reader and writer. So here in action server, we have the 3 action, one for send goal, cancel goal, and get result. So for that you need to create 6 topic, and you need to create the corresponding data readers and writers. And for the ROS discovery info, at DDS side you have the data writer, so that you can reconstruct your ROS node, and it is very useful into the ROS tooling and the client side. So now we introduce the Zenoh bridge. So here you can see we map the DDS publisher with the Zenoh publisher, and DDS subscriber with the Zenoh subscriber. But for the request and reply topic, we introduce the Zenoh queryable. So in Zenoh there is a notion of queryable. So there is a single entity that get the request and send the reply back. So single entity that handle both the received request and send the response. So it was not there into the ROS2 RMW middleware. So here you can see by this way, by using the queryable, you reduce your entities, and it provides the very efficient way for communication. So at the client side you can see we have the bridge at client side. So for the sending the request and receiving the response, we introduce get. So in Zenoh we have the notion of get that is responsible to send the data and receive the response. So now we have one more concept in our ROS2 in our Zenoh DDS bridge, ROS2 bridge. So that is the scoping mechanism. So for that we have the concept of namespace. So in ROS2 the namespace concept is there, but you have to set that, you have to define the scope at the application level. But here you can define the namespace or scoping at the on the fly at the bridge side. So you can configure, and no need to define that on the node ROS node level. So using the scope you can isolate the communication. So here you can see we have the turtle boat, and we define the boat 1 for the bridge 1, and the client side we use the same, and in the R bridge we get the data from the turtle boat 1, and below we define the bot 2, and so bot 1 doesn't get the data from bot 2. So if you want to isolate your robot communication, then you can use the namespace mechanism used in our new Zenoh bridge. So, but in fleet management use case where your fleet manager want to get the data from so yes, so our new Zenoh bridge is very optimal, and it have the better support for ROS tooling, and we have on the fly configuration for namespaces, and we optimize the service and action by the queryable, and we have new concept, the liveliness token. By using that you can assert the liveliness by using the single string. So by using that you can optimize the ROS2 communication. So because I am running late, so if you have any question, then yes. Thank you.
Sorry, in the interest of time, we'll have to skip the Q&A for now. But for any questions regarding Zenoh, you can meet Vivek offline and get through your questions. Thank you so much, Vivek, for the presentation.